Anyone need help getting to the Nearpod? Please try not to be distracted by that. It's totally going to light up and it's totally going to be boiling in a moment. It's kind of cool to watch. And I apologize, but I have to do it so that we have it ready. All right, so lesson 2.1. So in the previous lesson, we discussed how the appearance of a substance changes during the phase change. You did that through the videos. And we talked about the solid, the liquid, gas, how it changes, right? The solids don't, the gas changes the shapes of the rooms, the containers, and the liquids take the shape of the container as well. You also learned about the 3 key concepts that we just talked about. Let's do a review of these key concepts on the following slides. I'm going to go fast because we just did this. A key concept, the first one, a solid holds its shape and does not take the shape of its container. Okay? I explained that during the review. A gas has no visible shape and fills its container. And a liquid flows and can take the shape of its container. Having knowledge about the differences between the phases that are shown on these key concepts, it's not enough to help us solve the mystery of the methane, right? We can't figure out what's going on just knowing about the solid, liquid, gas. We have to know a little bit deeper. We need to understand more about what makes the phases different and what happens during freezing and evaporation. What's going on during those processes? Everything that happens during a phase change cannot be observed with the human eye. So when you watch those videos, you can see the melting, the evaporation, the condensation, and that's great, but there's more going on than we can see with just our eyes alone. We're going to observe substances on 2 scales, and I know you talked about scales last year. I think it was during your metabolism unit. I think it was your first unit. Where you get really deep down to like the cell level or the molecule level and the parts in your body like amino acids and proteins. Okay, so we're going to kind of be talking about those different levels again. And our 2 levels are macro scale and molecular scale. Macro scale, oh, hold on, not yet. Scaling is a word that scientists use when comparing the relative sizes of objects or substances, such as the size of a molecule compared to the size of a human, consisting of molecules. So we're comparing what makes up something compared to the whole thing. Molecules are very tiny units of matter that we cannot see with the naked eye. So they're tiny, tiny, tiny little things. The term naked eye, kind of silly, refers to our ability to observe a substance without the help of instruments. So our eyes are naked in the sense that we're not looking through a microscope. Okay, we don't have any tools to help us. This is a term we're going to use in the unit. We can see this water or even a single drop of water with our naked eye. So we can see the water in that cup. You can see a drop of water. You can see the condensation forming on the metal glass in those videos. We can see ice. We can see all that with our eyes. But in contrast, we need tools such as microscopes to help us see molecules. Molecules are very tiny units of matter that we cannot see with the naked eye. In this unit, we're going to be studying substances at both the macro scale, with just your eyes, and the molecular scale. So in the picture there, we see water. The water that you see there with those little atoms, the red and the gray circles, those molecules, looks very different than the water you see in your water bottles, right? You don't see a bunch of little circles floating around in your water bottle. But those are the molecules, the H2O, that makes up the water. So molecular scale is looking at those little individual particles or molecules. Scale is the relative size of things. A molecule is a group of atoms joined together in a particular way, like H2O. We're going to gain more experience with phase change by observing substances in different phases at both the macro and the molecular scale. To make observations of different phase changes, you're going to watch a video of students conducting an investigation. And in the video, you will first see a foam cup filled with hot water. I'm going to do the experiment as well and kind of walk around and show you. So you'll have the video and you'll have it in front of you. An empty plastic cup will be placed on top of the foam cup. You're going to observe any changes that occur after this setup happens. The water didn't boil. So you're going to watch the video on the next slide and make any observations of phase changes that you see. Remember phase changes: evaporation, melting, condensation, freezing. All right, so I want to have you play the videos. Are they on your screens, the video? Okay, go ahead and watch the video. I don't think there's volume. If there is, you will. I think. I have a cup sitting there on a cup on my screen. That video. You just hit play. This. Okay. Mine's on the video. Should be good. I think the process already happened. We'll just sit here for a minute and then we'll bring them closer to it. All right, so you should have watched that video. Did yours play yet, Cody?
Oh, yeah, no, it is.
Okay, let me know when it's over. Oh my goodness, look at this first one. It's so hot, it's like collapsing. So like you might have to look super, super close to see the water droplets like you saw in the video because they really zoomed in the video.
Yeah, the other ones are both of them looks like are all big ones.
Yeah. Guess my water didn't need to boil super close. You should go to the water droplets. Okay.
Because they'll go at high grade.
Yeah. So here's our cups. Put them in our camera. I don't even know if the camera can see them. See the little water droplets, but there they are. Okay. All right, so we're gonna go to Google Classroom and open up the document number 2 for today. So week 17, number 2. Click on the document. So you do have a link at the top of that document to watch that video again if you need to. And just 2 quick questions. What did you observe happening in the cup? And did a phase change or phase changes occur? And if so, which ones? So to kind of help you with that a little bit, I want to put up this slide. So there's our phase changes, okay? So in the first question, you want to describe what you saw, and I'll come around with the cups again. You can also watch that video again, a sentence or 2. And then the second question, which of those 4 phase changes do you think was occurring? And did it ask why? Nathan, what's the second question asked?
Did a phase change or phase changes occur? If so, which ones or what?
Okay, so you just have to say which one, okay? So if you think a phase change occurred, which one do you think occurred? If you want another look, you're welcome to have another look. I'll set them on the back counter here. You're welcome to get up. Any help? Just raise your hand. I'll help you. Mm-hmm. Yep. Well, did we start with a solid? No. So we started with the liquid, right? So all you have to really say is which phase change. Did a phase change occur? Yes, a phase change occurred. And say that it was evaporation. Nice. And there could have been 2 phase changes. There could have been more than 1 phase change. So try to think a little deeper if you're stuck. I'll tell you there's definitely 1. There could very well be 2. When you're done, you should turn that in.
Maybe I thought I have a little printed on the top of it.
Yes, isn't that nice? You can just turn it right in Google Docs. And if you're stuck, you should be focusing your thinking on the liquid and the gas, because we didn't have any solids. I mean, the cups were solid, but we weren't dealing with those, right? We were just dealing with the liquid and possibly the gas. When you're done, go ahead and turn it in. So in the video, we couldn't exactly observe the water at the molecular scale. We didn't see the molecules, did we? No, right? We can't see those molecules with our naked eye, with just our eye alone. Even with a hand lens, you couldn't get down and to see the individual molecules. But what did you observe at the macro scale? What did you see happen? Cody?
Like some wrinkle.
Some what?
Some cups wrinkled or wrinkling.
Oh, okay. The cups did wrinkle from the heat. What did you observe about the water? What happened with the water?
It evaporated.
It evaporated. So the hot water that I poured into the styrofoam cup evaporated. That means it turned to a what?
Yes.
A gas. But what did we see on the cups?
Condensation.
Very good. On the cup, we saw condensation. So evaporation did occur, but then condensation occurred on the plastic cup. So we had two phase changes that were occurring, evaporation and condensation. We're going to skip that. So you may have noticed evaporation, liquid to gas, and condensation, gas to liquid. Some evidence of evaporation was the steam above the styrofoam cup. The evidence of the condensation was the water drops that appeared on the clear cup. These drops were water vapor in the air condensing to liquid water on the walls of the cup. We're going to skip that for now. So you've thought a lot about macro scale appearance of phase changes today and in the previous lesson with our naked eye, what we can see. These are the changes you'll see with your own eyes. Tomorrow's lesson, you're going to focus on the molecular scale, what these changes look like in terms of the molecules. And I would hope that you would realize you're going to use a model or a sim to do that. So tomorrow's lesson will be using the sim. If you're confused as you're working, remember I will record first period and I will post it by 9 a.m. So you can always look at how we did it in class to help you with that assignment. I will clean your desks. Have a great day. And you can always email me if you're confused tomorrow.